In this latest instalment of the series of videos where we were thinking about calculations you might be called upon to make in molecular biology, we're going to think about solutions that involve making an intermediate because it's too big a step to go from your starting point to the final solution that you need. As usual, let's start with a worked example. Working from an initial stock of 0.5 micromolar dCTP, describe how you would make a dilution sequence comprising of 50 nanomolar, 5 nanomolar and 50 picomolar dCTP solutions. You should initially make 100 microliters of each, but you are permitted to use some of the intermediates in the preparation of the more dilute solutions. Note you are advised not to pipette volumes lower than 2 microliters at any point. And it's just worth pointing out that some micropipettes you can accurately pipette a bit lower than that, but this is the type of situation you'll be presented with a description and a limitation of some of the factors involved. So let's have a look how you would work through this. And the first thing that I would do in a question like this is to literally sketch out a series of tubes, just simple triangles in the way that they're done here, and indicate what I know already in terms of the concentrations that I've got, but also the volumes that are involved. So I'm starting from a stock of 0.5 micromolar, which is also, as we know, 500 nanomolar. I'm then asked to make solutions at 50 nanomolar, 5 nanomolar and 50 picomolar, and to have 100 microliters of each of those. So for me, the first step then is to think, well, what is the dilution factor involved in each of those stages? And in that first transition, you're dividing by 10, it's a tenfold dilution. That's true for the second step as well. And for the third step, that's then a 100-fold dilution. Now, if we want to end up with 100 microliters of 50 nanomolar solution, and it's a tenfold dilution, we are therefore transferring into that 10 microliters of our stock, and we're adding it into 90 microliters of water. The same is going to be true for the next step because that's also a tenfold dilution. And so 10 microliters is taken from our 50 nanomolar solution, and that's transferred to make our 5 nanomolar by adding it to 90 microliters of water. The third step, from 5 nanomolar to 50 picomolar, is a 100-fold dilution. So that's a rather larger change that we've seen previously. If we tried to make that directly, then we would need to transfer 1 microliter into 99 microliters of water. But you will recall from the question that we were told that we should only transfer a minimum at any stage of 2 microliters. So what are we going to do? Well, as I've given you a bit of a steer here with the layout of this slide, we're going to have to work through an additional solution on the way between the 5 nanomolar and the 50 picomolar. And so we're going to go through a step of 0.5 nanomolar, which then means that rather than a 100-fold dilution step, we've replaced that with 2 10-fold dilution steps. And so essentially the steps are all now equivalent. At every point in this particular example, we're moving 10 micromolar of one solution into 90 microliters of a different solution in order to then produce our dilution sequence. One of which we don't need at the end of the day, it's just a step along the way. Okay, so as usual, we want you now to have the opportunity to try one of these for yourself. And in this particular case, what I've done is to take the same scenario but introduce a different twist. So now imagine that you need the full 100 microliters of each concentration. That's the 50 nanomolar, the 5 nanomolar and the 50 picomolar. You need to have those for your experiment. How would this alter your strategy, bearing in mind that dCTP is expensive and therefore you ought to use a minimum quantity whilst not violating the advice regarding minimum volume to pipette, so the 2 microliter minimum volume. And you're reminded that the stock is 0.5 micromolar. So a few moments, I suggest that you pause the video at this point, have a go at the question for yourself, and then we'll work through this question again. In this particular scenario then, the difference is that we're being told that we need our full 100 microlitres of each intermediate solution. So we can't draw from those to make the more dilute solutions. So what are we going to do in this particular case? What I would say therefore is that you need to consider each of the different steps in turn. So to begin with, let's think about the step in which we go from the 0.5 micromolar to the 50 nanomolar. In this particular step, we're going from 0.5 micromolar DCTP to 100 microlitres of 50 nanomolar DCTP. What are we going to do? Well, actually, this step is unchanged from previously. This is the same as we've done before. We're going to need to take 10 microlitres of our stock, transfer it into 90 microlitres of water, and that will make our 100 microlitres of 50 nanomolar solution. The point is though, we won't then subsequently be able to take from that because we need that. So we've got to think about the other steps separately. So moving on then, 0.5 micromolar DCTP, now we're wanting to make 100 microlitres of 5 nanomolar. This is what we did previously, but notice that we are using 10 microlitres of our initial solution here, which actually we don't need to use that much. We don't need to end up with 100 microlitres because we've got that in a separate reaction. So we want to minimise waste, and so our crucial thing to factor into that is that we can take less than 10 microlitres. We can in fact take 2 microlitres instead. So how much are we then going to actually need to make? And so what we've got here then, we are taking our minimum of 2 microlitres. It's a tenfold dilution. So that means we're going to need to make 20 microlitres of our first intermediate, and we'll do so by adding 2 microlitres of the stock into 18 microlitres of water. Now that's sufficient because we've got 20 microlitres overall, and we're going to take 10 microlitres of that. So that's fine. We've ended up not wasting 8 microlitres of our original DCTP stock. Moving on to the next step, this was how we did that previously. And so we added our intermediate along the way. We're still going to need an intermediate at that point, but what we don't need this time is 100 microlitres of each of these. We can essentially get away with 20 microlitres as we had in the previous case. So rather than transferring 10 microlitres into 90 microlitres, at each of those steps we can transfer 2 microlitres into 18 microlitres of water, and that will give us sufficient in each case to then produce the final solution that we need without wasting materials along the way. But it's actually better than that, because we've previously made this solution and we didn't use all of it up. Remember, we transferred 10 microlitres out, so we've got 10 microlitres that still exists from having made our 5 nanomolar intermediate. So we don't need to do this first step at all. We don't need to go back and take any more of the original stock. We can instead work straight away from our intermediate here. And so that's what's presented here in the final slide. We've gone from our first intermediate that we made. Remember, we had 10 microlitres left over. We only need 2 microlitres from that. And so in that way, we can minimise the wastage that we've made. Now, as always, there's other ways that you could answer a question like this, but these steps fulfill the various criteria that were imposed, the fact that we're trying to minimise the waste that was included.